Okay, Miss Jensen,
Yeah,
would you mind going over a question from the last quiz?
absolutely. Which question?
Um, Solving cosecant of 5 pi over 12.
Yes. Okay. So we'll start off by sharing my iPad here. And so one thing that you need to know is the identities I give you are you can't apply those to the reciprocal. You cannot apply those to the reciprocal functions. So meaning cosecant of 5 pi over 12, you can't just use the identity. You can't, it's not the same identity for cosecant. So in other words, you have to find the sine of 5 pi over 12 first using the identity. And then we know the relationship between cosecant and sine is reciprocal the ratio. So if we find the ratio of sine of 5 pi over 12, we just flip the answer. So again, so cosecant, and the big mistake that some people sometimes make is they flip the angle, but it's the flip of the ratio. So cosecant of 5 pi over 12 is just 1 over sine 5 pi over 12. So if I can start off by finding sine of 5 pi over 12, then I can just flip my answer at the end. So one helpful thing is whenever you see an angle, it's going to be in terms of pi. If it's an angle that doesn't have pi in it, this doesn't apply. But if it's an angle that has pi in it and it's not an angle we know, you want to think, is there some difference identity that I could use? Could I break that up into two angles I know? So what do you think what are two angles? Like what adds to 5 pi over 12 that I might be able to use?
Pi over 4 and pi over 6.
Yeah, because you could do 3 pi over 12. As you just said, it's pi over 4 plus 2 pi over 12, which is pi over 6. Exactly. So you've got sine of pi over 4 plus pi over 6. And you can't distribute, so you have to use your identity. So sine pi over 4, cosine pi over 6, plus cosine pi over 4, sine pi over 6. And honestly, the hardest part about this, once you realized you had to take the sine and then just flip the answer, is you have to do some simplifying in algebra. So we've got root 2 over 2 plus, times root 3 over 2 plus root 2 over 2 times a half. So the sine is root 6 plus root 2 over 4. And so that's the ratio of sine of 5 pi over 12. So that means cosecant of 5 pi over 12 would be flipping that. So 4 over root 6 plus root 2. But I said you had to simplify in this case. So you need to rationalize by multiplying by the conjugate of the binomial root 6 plus 2. So this would give you 4 root 6 minus 4 root 2 over 6 minus 2, which ends up being 4 root 6 minus 4 root 2 over 4, or root 6 minus root 2. So once you got what to do, I felt like then the hard part was make sure you rationalize appropriately.
Yeah, okay, thank you.
Yeah. Who's next? Just jump in if you want.
Could we go over, I mean, any problem that has to do with like the bearings and yeah. But like can you think of like a challenging one that we could go over together? Because yeah.
Let's see. Maybe if you bear with me, maybe I make one up. Does that sound okay?
Yeah.
Okay, so let's think. So I'm going to use a ship. A ship starts out at a port and travels on a bearing of, let's do, what do I want to do? Let's say 210 degrees for let's do for 25 nautical miles. It then turns and travels. Watch me make something up that ends up being 90 degrees. I'm hoping not to. It then turns and travels on a bearing of, all right, give me a second while I make sure this works out. Hold on 1 second.
Okay.
I'm gonna sketch something just to make sure that I get this right. All right, so 210, then for a certain time, and travels on a bearing of. Okay, yeah, so let's go. Let's do 305 degrees for 40 nautical miles. How far is the ship from port? And on what bearing does it need to travel to return to port? Does that make sense, the question?
Yeah.
Okay. Okay, do you guys want a minute to try to draw this, or do you want me to walk through this, or what would be helpful?
Maybe like a minute to try to draw it out.
Yeah, I
Okay.
think that would be great.
Okay, I'll give you, and I'm going to do the same, and I'll yelp if I need to adjust. I think I did it okay though. Again, I'm just making this up off the fly here. All right, so for those just joining, I just made up a bearing problem for people to try, and then we'll go over it together after people give a chance to give it a go. At least give the drawing a go. Yeah, this seems like a good problem. It's similar to the one that I gave. The people who took it early had a problem similar to this. You want more time, or what do you want? You guys tell me what you need.
We have another maybe 30 seconds or so.
Okay, Zachary, we'll give you that.
Thanks.
Okay, let's see if we have the drawing right here. And it is helpful to kind of try to be as accurate as, I mean, you're not going to be perfect. We're not doing a protractor or anything, but if the longer side 40 should be longer than 25, for instance. So try to because it'll be that much easier to figure the bearing in particular out if you, oh geez, if you draw things accurately or somewhat accurately. Okay, so we're starting out at this port. And remember, when we start out, we always draw this. I find it helpful, especially with non-right triangles, to draw this north, south, east, west line. And traveling on a bearing of 210. So from the north, we'll go a little bit more than 180. I tend to fill in the angles as I go. So that would be 10 degrees. And this angle here between the west line and my line of travel would be 80. And so I'm going for 25 nautical miles. And then we're turning and going for, what did I say? 305. So
Wait, sorry, why is it 10 degrees? Maybe 30?
Oh, 30. Sorry. Zach.
Okay.
Thank you. Not 10. Oh, sorry. Thank you. 30. And so the other one would be what? If it's 30, then this one would be
60.
60. Yeah. Thank you. Yeah. It's not 200 plus 10, it's 180. Okay. And then turning and going for 305. All right. So a little bit more than, and this time, oh, I wanted to do this color. This time we're going to go longer. Going to go for 40. And again, I want to fill in my angles. If from 270 to 305, what's this angle right here? From 305 to 360.
55.
Yeah, 55.
Yeah, 55, right. So 55 here, and this one then would be 35 degrees. And you're going to see this ends up being helpful, particularly when I'm trying to figure out the bearing. Okay, so the final question was, two questions actually. How far to get back to the port? Should have labeled this. So we're going to find that. And I know that this is 40. And the other question is what is the bearing to get to my line of travel? So I want to find this angle here, because I always go from, if I'm finding a bearing, I go from north of where I'm starting and I draw an arrow going clockwise to the line of travel I want to go on. So that red arrow there is the angle I need to find for my bearing. Okay, so we do know some things. I know two sides. Do I know this angle here?
Yes.
Yeah, because what do I know the 55 part? What's the other part?
30.
30, right? So that's why it was alternate interior angles, because I knew this right here was 30. I know the other piece is 30. So that's why filling in angles can be very helpful. By the way, this angle is not 60. 60 is from that line of travel to the dotted blue line. So be careful about that. Don't misinterpret that for being 60. That is not 60, that whole angle. So I know this, I have SAS. I know I've got the 40, the 25, and that would be 85. So what am I going to use if I have SAS?
Law of cosines.
Law of cosines, yeah. So I'm going to say x squared equals 40 squared plus 25 squared minus 2 times 25 times 40 times the cosine of 85 degrees. And then you're going to do that. And I do not have my calculator. So if anyone has a calculator on them, tell me when you take the square root, what the heck x is.
43.53.
43.53 nautical
miles.
miles. Okay, I'll just say NM. Great. All right. So now a couple other things. So to get this bearing that I have, what's going to be helpful? What overall, what is the strategy I can use? It's going to be 180. How am I going to find this bearing? I know this angle here. What's that angle?
55.
It's 55, right? Again, alternate interior. Doesn't really look 55 based on how I drew it, but it's 55. And so the bearing is going to end up being 180 minus 55 plus what other angle? I need to find this angle. I'll call it Y. Do people agree I need to find that angle in my triangle?
Yes.
Okay, how can I find that angle?
You can do like 180 minus 60 minus 85.
Well, careful, Danae, because this angle is not 60 here. The 60
Oh, right.
from the line of travel. So I actually don't know what that angle is yet. So the only angle I really know in this triangle so far is that 85.
So you
If I
gotta
get
use
that
law
angle,
of sines.
100%. I would do law of sines. That's exactly right. Let's do law of sines. So, and this is so typical, like now that we've done, I mean, this is a very typical problem for now that we've done law of sines and law of cosines and working with non-right triangles. So if we did sine, oh, I don't want to be in that mode. If I did sine of y over what?
Five.
25, yeah. The opposite side is sine of 85 over what I just found, 43.53. All right, so someone, solve for sine y, and then someone tell me what angle y is.
I got 34.9 degrees.
34.9. Do I have a second to that?
Yeah, I got the same thing.
Great. Okay. Since I'm not doing it, I'm relying on you guys. Okay. So the bearing, so someone do the bearing is 180 minus those two added together, and that would be the line of travel you would go on.
Could you also do it? Oh, sorry, never mind. Or wait, could you do it using the side with 60? So then like, I guess you could find the side with 60 and then minus 60 to get that little angle and then add it to the top and do.
Yeah, sure. So yeah, you could find what that angle is too, right? And find what that little piece is. Yeah, you could have done that too.
Okay.
Yeah, I could have found that angle instead. You're right. And just found the bearing that way. Yeah.
Wait, I got a weird bearing. I got like 90.1.
Yeah, that sounds good. Why do you think that's
okay.
weird?
I don't know, it's a right angle or like
Yeah, it's a
close to-
little bit more than a right angle. Yeah, which I'm not actually surprised. I mean, because I knew that, remember we were saying this was 50, this angle here is 55, and obviously my drawing makes it look much less than 55. Yeah, so the bearing is just over 90 degrees. So it's almost a 90-degree angle there, but my picture actually doesn't make it look that way, but yeah, no, that's right. Mine looks like, I don't know. It looks like the bearing would more be like 100, between 100 and 110 or something, but nope, that is right. So how did that seem?
Manageable.
Manageable?
Yeah,
So it's literally just like they're almost always fall, now that we've done law of sines and law of cosines, that this is like a very typical type of problem. So just being careful with your angles, filling in angles as you go, trying to be accurate. I mean, obviously I wasn't that accurate. I didn't intend for it to be.
Holy shit, what do you want?
Oh, hello. Maybe. Was I the only one who heard that?
Nah.
I heard it too.
It happens. I'm glad it wasn't from my house. That's all I have to say, because it happens here. Okay. Not by me, of course, by my children. What else you got for me?
Could we do some of the ones similar to the on the review packet, the last page, like a triangle one, or the like 28 was in, but I didn't know how to do that.
Oh, let's not spend time. Those were, all right, 28. I'll just talk a little bit about 28. That sigma notation was to see how many of you remembered from the homework how to do that. I'm not going to put something like 28 not on now, but we are, after we do conic sections, going to talk about sigma notation. So it's just kind of reminding you about that. But this last page, Zach, is not, it was just kind of giving you, for those who wanted some more challenges, like putting some stuff together. But they're harder than I'm going to give.
Okay, sweet.
Happy to go over with you, but I just don't want, since people want to do ones that are kind of similar to they're going to see, I just don't want to take up time if there's other questions.
Yeah, okay.
Did we do 25 on the review packet?
I certainly could, but I won't have graphing on this.
Okay, no worries.
Let's save that till before, I'll have a Zoom before the cumulative. So, and I put some of those types of problems like 24 through 28 are really, well, 24 and 25 are more for the cumulative. So, but Elizabeth,
okay.
if there's no more questions, I'm happy to ask, or we can just wait to talk about those.
Yeah, sounds good.
Could we do an ugly identities one then?
Ugly, what do you mean by ugly identity?
I don't know, like approve the identity, but
Oh, Zachary, these are so hard for me to make up though. I don't know if
okay.
I can make one up on the fly. Let me see. Give me a second. There was one that someone did a makeup quiz for me today. Oh no, that was not proving an identity though. If I think of one, Zach, they're super hard to make up. That's why I'm
Okay.
hesitant.
Yeah, no worries.
Takes a while to make sure that it actually works. Bradford, you have a question.
Yeah, is 26 on the trig review packet, is that like a problem that we would see on the test? And if so, could you do it?
No, 24 through 28 is not like you will see on this.
Okay, all right, thank you then.
I mean, it has a lot of cool elements to it, but no. We haven't in this class formally talked about circles. We're about to do that next in conic sections. So it was me trying to connect it to something we're about to do, but no, don't have to worry about that for the test.
All right, cool, thanks.
Nathan, what you got?
Could you go over 4A on the quiz?
4A on which one?
The quiz.
Oh, on the quiz, sure. The last quiz, which one was? Hold on, give me a second too. Oh yeah, okay. So this is something you definitely want to make sure you understand. So 4A, this was a solve, and I said solve in between 0 and 2 pi. And remember our solving strategies. If it's one trig function, great, isolate it. If it's more than one, the next strategy is, could you factor something out? And so on this problem here, I realized that, okay, I've got more than one trig function. What you cannot do when you're solving for something is ever cancel out a term that involves the something you're solving for. It's one thing to rewrite it in terms of a different trig function, but canceling it out altogether is a no-no. So in this case, a lot of people did this, but you totally lose solutions when you do that. So when you're tempted to do that, think about, okay, if I bring everything to one side, can I factor out and take out a GCF? And that's exactly what you want to do. So when you have more than one trig function and there's not an identity involved, think about factoring out whatever's common. Oops, that should be a cosine. So if I factor out a cosine theta, I'm left with cotangent theta minus 2. And so once it's in factored form, it has to have 0 on a side to be in factored form. The only way something's 0 is if one of the factors is 0. So you've got cotangent equaling 0 and cotangent being 2. And when is cosine 0? It's when x is 0, so pi over 2 and 3 pi over 2. And again, because I asked between 0 and 2 pi. So on the test, you are going to have your calculator, and I'm going to it's going to be necessary for you to understand or know, not understand, know when, okay, I know when cosine 0, so I can find the exact angles versus tangent being a half, which is the same as cotangent being 2. That's not a special angle, so I got to turn to my calculator here. So on your calculator, when you do inverse tan of a half, you get, I think we get 0.46. And that's in quadrant 1, but because I want all angles between 0 and 2 pi, tangents also and cotangent are positive in quadrant 3. So to get the quadrant 3, I would do pi plus 0.46, which is 3.6, about 3.6, 3.61. So that's that. So yeah, factoring out is a big strategy.
So generally you want to get all the trig functions on the same side. And,
Yes.
whatever integer value on the other side.
Yes.
So for like 4b would be an example of where you put the integer value, right, on the right side.
Yeah, because you have a single trig function, right? So you can isolate this. Yes, exactly. Chloe, what you got?
So I have 2 quick questions. So the first one is, are you going to give us all 3 of the law of cosines?
No, you'll get none of those.
Oh, okay.
You get the same exact identity sheet as last time, as the quiz.
Okay, so I have to memorize that one. And then for my second question, can you go over like due east and then like due west for bearing problems?
If something's traveling due east, you mean?
Yeah.
Yeah, so that just means it's not going on any particular angle. So yeah, so if something was traveling, so say a ship is traveling due east, that means if I think about the north, south, east, west, so north, south, east, west, then the ship is literally traveling along this eastern line. The same would be true if a ship was traveling due west. We'd be traveling on this line. So again, I always do draw my north, south, east, west, but instead of going at an angle from there, I'm literally just going on that line of the line of direction.
What about like due east 30 degrees?
So I would never say due east 30 degrees. I would either say 30-degree bearing, which means from the north. So everything's from the north. If there's no direction specified, it's from the north clockwise, right? But if I do specify direction, it's one of 4 things. It would be north, some degree east, or it could be north, some degree west, or it's south, some degree east from the south line, or south, some degree west. I would never just say 30-degree east.
Wait, how would you do those again? Sorry.
So from the north, like north 30 degrees east, it tells you from the north line, you're going 30 degrees in the east direction. Whereas if I was going west, it'd be from the north line 30-degree west. And the same is true, so those are north. The same is true if I were doing south. From the south, so again, I'm drawing my north, south, east, west line. From the south line, if I'm going east, I'm going here. And if I'm going west, again, from the south line, I go to the left. Those are the only possibilities.
Okay, that makes sense. Thank you.
Yeah. Yes, Zach.
Could we do 2F from the quiz or a problem like 2F, something like it? I always mess it up.
Oh, yeah, I know it. I don't even have to look at it. I know which one you're talking about. Okay, this I gave on a makeup quiz. We'll do this one, and I'm going to give you guys a chance to think about it. Okay, so what if I said, all right, let me make sure that I'm thinking of it. I think I did. Well, we'll try this way, even if this isn't exactly what I did. I think I did this. So inverse sine of cosine 2.5. So people take a moment to try that. And you want your answer in terms of like 2.5 and pi or 2 pi, or don't give me, other than 2.5, don't give me decimal answers. And also, so I think I actually meant to do the other one too. So let's just do it. Try this one too, if it had been the other way around. What do you think? Should we try it, or you need more time? Let's start with one, the first one. What's the first thing you want to think about?
What quadrant the angle is in?
Yeah. So even, and maybe even before then, recognizing that 2.5, some people jump to creating a triangle, but in this case, 2.5 is standing for an angle. So you're not going to do that. Yeah. And so 2.5 is in what quadrant, that angle?
2.
2. So if this is in quadrant 2, is cosine of a quadrant 2 angle positive or negative?
Negative.
Negative. So I'm doing inverse sine of a negative ratio, and that will tell me what quadrant do I want my answer to be in.
The quadrant 4.
Yeah, so based on the range of inverse sine, if you're doing inverse sine of a negative ratio, I want a negative quadrant 4 angle. So ultimately, that's what my answer needs to be. Okay, so then you really can't do anything until you change cosine, the inside cosine to sine. So how can I rewrite that?
Pi over 2 minus 2.5.
Yep, sine of pi over 2 minus 2.5. Okay, so then I think about, okay, inverse sine and sine undo each other, but when I get this pi over 2 minus 2.5, is that in fact what I want? What quadrant is that angle in? Is it a negative quadrant 4? If it is, yay. If it's not, how can I manipulate it to get what I need?
It is negative quadrant 4.
It is, right. It is. And you guys will have a calculator with you, so you could always check to see what decimal that is. Like I think pi over 2 is about 1.57. So, and I recognize that, oh, okay, that's going to be a negative quadrant 4 angle there. So I'm done. Like that's exactly what I wanted. But that's why I wanted to do this next one. Because this next one's not quite that. So let's think about this next one. So sine of 2.5, 2.5 we said was in quadrant 2. So sine of 2.5 is going to be positive or negative?
Positive.
Yep. So that means if I'm doing inverse cosine of a positive ratio, I want a quadrant 1 angle. So an acute angle, positive. Okay. So same idea, inverse cosine of cosine pi over 2 minus 2.5. And we already know that this angle, we said, is a negative quadrant 4 angle. And I want a quadrant 1 angle. So how do I make that happen?
Make it positive.
Yeah, so how do I do that? You're right, but what do I do to make it positive?
Is it 2.5 minus pi over 2?
Yeah, you just multiply it by -1, right? So multiplying this by -1, making that positive is it's 2.5 minus pi over 2, right? Because a negative quadrant 4 angle, it's a negative acute angle. So just to make it a positive acute, just think of multiplying it by -1. So that's kind of the process you want to go through with those is, and again, you'll have a calculator if you need to figure out where the heck is this angle falling. Yeah, so those are good to go over. What else are people stuck on or worried about?
Could you go over question 8 on 7.8?
Question 8 on 7.8. Let me pull it up here. Oh, yes. Okay. This is the one I said you guys should know how to do, right, Elizabeth?
Yeah, exactly.
And I'm still going to say, yeah, you should know how to do something like this. Okay. So, I don't know why I expose you guys to arcsine, but then whenever I get an arcsine problem, I just don't like arcsine that much. So I'm going to change it right away, and I just do this. So if you love arcsine, I'm sorry, but I'm just going to change it. I prefer working with this. Okay. So what do you have to do here? You have two terms with variables inside inverse sine, which is not fun. So what should one do?
Were these the ones where you had to like bring one to the other side?
Well, you tell me, Zach. What do you think?
Yes, but what, like, how do you know which one to bring?
Oh, it doesn't matter, actually. So you could bring either. My preference is always the one that's more complicated, like the 2x, I'm going to isolate, but it doesn't really matter.
Okay.
I just kind of choose to always do that, but because I don't like creating a triangle with 2x over 1, I'd rather create it with x over 1. So I tend to do the more complicated, isolate that. Yeah, so you cannot just take the sine of both sides, because people are tempted to take the sine of both sides and distribute the sine. No, we have an identity for sine of a sum, so you cannot do that. I mean, you could do the identity, but then you get a whole big mess. So isolate one. I'm going to choose to isolate this one. And in order to get a variable out of an inverse trig function, you have to take the inverse of it. So in this case, I'd take the sine of both sides. So you've got 2x equals, and then it's important to recognize on the right side, you cannot distribute sine across. You have to use the sign of a difference in this case. So I'm going to use that identity. So sine of pi over 2, cosine of inverse sine of x, minus cosine pi over 2, sine inverse sine of x. And then you start to simplify what you can. So what is sine of pi over 2?
I have a question.
Yes.
Could you change? Actually, I don't know. Never mind. I'm good.
You could. I think you're getting at, could you change sine of pi over 2 minus inverse sine of x to
Yeah, that was my question.
Good, 100%. And that's exactly what we're going to end up getting anyway. So yeah, if you recognize that, you totally could. Just because if it was not pi over 2 minus, you couldn't, but because it is pi over 2 minus, I could have changed this whole side to cosine of inverse sine of x, which, by the way, is what we're going to end up with anyway. So yes, you totally could have done that. Sometimes I hesitate to go down that route in this case, because that's not always going to be the case. But yeah, if you had pi over 2 minus, yes. If you have like pi over 3 or something else, you can. So yeah, sine of pi over 2 is 1. So we get cosine of inverse sine of x. And Harry, like you said, notice that cosine of pi over 2 is 0. So this whole other part goes away. So you're just left with exactly what you would have if you recognize the sine of 90 minus an angle is cosine of an angle. Okay, so now what? I got to solve for x. So I haven't solved for x yet. What do I do now? Do we know what cosine of inverse sine of x is? All
Can
right,
you
let me
draw a
ask-
reference triangle?
Yeah, and I was just gonna ask, is X in this case on the right? Is X on the right an angle or a ratio?
A
Is this,
ratio?
it's a ratio, yeah. So with an angle, you can't draw a triangle because that wouldn't make sense unless you knew specifically what that angle is. I guess you could draw the angle. But with when it's a ratio, yeah. So let's draw a triangle. This means the sine of some angle equals X over 1. So let's draw that. So I've got X over 1, and that allows me to get the horizontal here, or the adjacent, which is the square root of 1 minus X squared. And now I can take the cosine of that angle. I don't know the angle, but I can take the cosine of it, which would be the square root of 1 minus X squared.
Miss Jensen,
Yes.
if you gave us like say sine of negative X, then we would have to draw the reference triangle like not this, right? Like different quadrant thing.
It doesn't. You could draw it in any quadrant you want, because if X is negative, it's not going to matter. In other words, it won't matter in this case because you're doing the square root of 1
okay.
minus X squared anyway. It
Oh
won't.
yeah. Okay.
So
Okay.
yeah, so you don't even, I don't know why I put it in a quadrant. You could just draw it kind of anywhere, but I just get in the habit of drawing in the first quadrant. So then how do I solve for X here? How do I get X out of square root?
Square both sides.
Yep, square both sides. And I always make a note, if I'm squaring both sides, it means I got to check for extraneous solutions. Inevitably, someone's going to forget that you got to square the 2 as well. So it's got to be 4x squared equals 1 minus x squared. So we get 5x squared equals 1. X squared is a fifth. So x is plus or minus this square root of 1/5, which is root 5 over 5. And then, and this was one that you're going to have to use your calculator to check, even though on this thing I said no calculator, but for this one, you would have to use your calculator to check, and you check in the original, and it turns out in this case, only the root 5 over 5 works. The worst is when neither works, but yeah, be suspicious on the test if neither works. Something should work. Does that help, Elizabeth?
Yeah. Thank you.
Yeah, those are the lengthiest type of problems, I feel like. You also should know, in addition to law, sines and law cosines, Chloe, you had asked about that. You should know that new area formula. People know that?
Which one? Sorry.
So the area where you don't have to do 1/2 base times height, which requires knowing some sort of, right triangle situation. The area of a triangle, if you have SAS, you can find an area of a triangle because it's 1/2 AB sine C. So 1/2 of 2, knowing the 2 sides, and then the sine of the included angle. So the same thing could be said 1/2 BC, but then it would be sine of what?
A.
A, yeah. So think of the area of a triangle. Again, you need to know SAS, 2 sides and an included angle. Or I could say 1/2, haven't I done? AC sine B. Because that's hugely helpful for finding areas, because it can be really complicated sometimes. Or just a lot more work to find an altitude in order to find the area by 1/2 base times height.
I was wondering what mode our calculator should be in for the test.
Great question. And I have kindly Sophia for every problems in bold said, make sure your calculator is in this mode. Make sure your calculator is in that mode. So every problem I tell you.
Okay, great.
At least every problem that you need a calculator. Not every problem you need a calculator, but anything that needs a calculator, I tell you in the problem what mode to be in. Because the truth is you're going to be in both modes. Because bearing uses the bearing and the application problems and the area problems use degrees, whereas some of the other like solving equations, you're going to be in radians. Okay, last question, Chloe. What do you got? Then I got to run.
Can you go over SSA when you have to like assume two triangles?
Yeah, so you always assume, so SSA is the only type that you assume nothing else can have two triangles. Only SSA is the only type of information that can ever have two triangles. So if you're getting two triangles for something else, something's wrong. There can only be two triangles for SSA. So for example, I'll try to see if I can quickly do this. So if I have, say I had 55, and we'll make this 20, let's make this 35. Actually, I'm going to make that. That's too big. Let's make that 35 degrees or something. Okay, so it doesn't exactly look 35, but pretend it does. Okay, so do you agree that this is SSA? Like if I go in the or ASS, like if I go in order, I have one angle and then two sides that with the angle not between the two sides.
Yeah.
Okay, so there's only one way to start. SSA, I've got to use law of sines, and the only thing I can do is sine 35 over 20 equals, let's label this BC, equals, oh yeah, sine C over 35. Okay, so tell me what C is. Actually, first tell me what sine C is, and then tell me what C is. What's sine of C?
$20.
Sine of C is 20?
Yeah.
35. Are you in degrees?
Oh wait, I didn't divide by 20. I got 1.
35 times sine. Okay, I definitely don't want it to be 1 because then this is going to be totally not work. So you did 35 sine.
You got 1?
Maybe.
I got 1 also.
Okay, all right, let's not do that. Okay, so let's make that's not what I want, because then you have a 90-degree triangle and I don't want that. So let's instead make it sine of, well, that's funny how that worked out. So let's make that sine, let's do 25 degrees instead of 35. So do 35 sine of 25 and then divide by 20 and tell me what you get.
I got 0.74.
Okay, so sine is positive. Do we agree in both quadrant 1 and quadrant 2? So, but when we do inverse sine on our calculator to get C, what do we get for C? Inverse sine of 0.74.
47.73.
37.73. Okay, great.
47.
Oh, 47, 47.13. So the question is, we just said sine is positive in both quadrant 1 or quadrant 2. So there's a chance that there could be a second triangle, and you always want to assume there is. And to find the other possibility for C, which we'll call C prime, you do 180 minus that, because that would be the equivalent quadrant 2 angle. So what would C prime be?
132.27.
Okay, so I'm going to assume those are my two possibilities. The question is, when I go to find A and B and B prime, does the second triangle exist? Because B prime is going to be 180, what all the angles sum up to, minus what I was given, plus 132. Oh, shoot, sorry. Plus 132 0.27. And is that going to give me a positive angle? Looks like it is. Right?
Yeah, 22.73 degrees.
Yeah, so then Chloe, that's, there are two triangles that are going to work here, because C, that first angle that I found, could either be a quadrant 1 acute angle, or it could have been an obtuse angle. And then
Okay, sounds good.
so then I would proceed just to find, it's so annoying because then you have to find, the missing pieces for both, but that's the only case where that happens. And where you would know it doesn't happen is when you went to find B prime, you would get a negative angle. Then you realize, okay, this acute one is the only one that works.
So for SSA and ASS, you always have to assume there's two triangles.
Always, yes.
Okay, thanks.
Until you prove otherwise. All right, people, you got this. We've had a lot of, I feel like we've had a lot of practice. So just, yeah, make sure law of cosines, law of sines, make sure knowing those formulas, law of sines, but law of cosines isn't that bad either. Okay. I will see you guys tomorrow.
Thank you.
Okay.
Yeah.
Thank you.
Bye.
Thank you.
Bye.